Okay, the idea is to see another rule, the quotient rule today, and tomorrow we're going to dedicate the class to work on both activities, this one and the previous one. Okay? And also tomorrow I'm going to check completely the previous one, the one of the 50 derivatives. So you haven't finished, but you have time to finish it today. Okay. Good. Ready?
Yeah.
Okay. So today we're going to see a new rule, the quotient rule. What's a quotient? Remember that a quotient is basically a division of functions. So when you have a division of functions, such as this example, we're going to apply the quotient rule. The quotient rule says if the numerator is called f and the denominator is called g, then the derivative is going to be g times the derivative of f minus f and the derivative of g over g squared. So basically it's very similar to the previous one, the product rule, just with a subtraction and the denominator raised to the square. Okay? Fine. Example. Here, I have f of x equal to x plus 3 over x minus 2.
X minus 2 times.
Question here. Can I simplify this?
Yes.
Can I?
No.
Or rewrite anything?
No.
I could rewrite, or a little bit more difficult. So the idea here is that I cannot simplify because in this case it's a binomial. And no, I cannot cancel n with x. Huh? No. In this case, no. So in this case, I need to apply the quotient rule. Now, f is going to be the numerator, g the denominator. So if we apply the rule directly, it's going to be the derivative will be x minus 2, yeah, times derivative of x plus 3. Just 1. Just 1. Why? Because the derivative of x is 1 and the derivative of 3 is 0. So it's 1. Minus x plus 3 times the derivative of x minus 2. 1 again. Over the denominator x to the square. And then if we can simplify the numerator, we need to do it. X minus 2 times 1 is going to be x minus 2 minus x plus 3 becomes x minus 3 over the denominator. No need to expand the denominator, okay? So that's it. You can even indicate it.
You cancel it.
And we cancel the x's, yeah? So the final answer is going to be? And that's it. Okay? As simple as that. Questions? No? Good. You can do it if you want to, and it's not wrong, but certainly it's very that way. Every time that I put prime, it will be a derivative. No, it's 1 in this particular case because the derivative of x plus 3 is 1. It will be different. We'll see more examples. Okay, second example. Okay. Second example. Now, h of x equal to 5x to the cube minus 2x over cosine. Can I simplify or write? No, not convenient. But we could check if we want to. But in this case, there's no need. So, again, this is going to be f, and this is going to be g, and then you need to apply the derivative. So h prime of x is going to be cosine times 15x squared. This is 3. This is 2. Minus 2. Minus 5x to the cube minus 2x times derivative of cosine. Negative sign. Very good. Over cosine of x to the square. Okay? And then we simplify. H prime of x is going to be multiply this times this, this times that, this times this, and this. So cosine of x, 15x squared is going to be 15x squared cosine of x minus 2 cosine of x. Then minus 5x to the cube times minus sign. 5x to the power of 3 positive sign and minus negative 2x negative sign minus or plus sign of x over cosine square of x. That's it. That's the answer. Yeah. Yeah. Why? Because there are some cases you can apply one rule or another rule. Sometimes it's easier than another one. So we can apply whatever rule we want. As long as it applies. Can you say?
How can we know that is the actual, like, the final answer?
Okay. How can you tell that if you have final answer? Can I simplify anything here? Not factor. Simplify. Doesn't mean cancelling or dividing anything? No. So in this case, you could factor the cosine perhaps you have the same thing as this. Or you have the sine, if I factor, I have this one. So no. Factoring is not necessary. Simplifying is necessary. But in this case, you can't.
So is simplifying not factoring?
Different stuff. Factoring is common factor, something like that. Simplifying is cancelling.
Teacher, but can you cancel those cosines?
You could, in a way, if you separate this as one fraction and this as another fraction, but it's just another way to see it. It's not simplified, so it's another way to see it. So it's the same. That's your answer. That's valid. No, that's both. But actually, that's why minus times positive is minus times minus becomes positive.
Ah, sí, pero o sea, ese menos no metió tal cual al minus sign, ¿verdad? O sea, solamente ya no meto multiplicar, que sea cambia.
Well, each one. Yeah.
Teacher,
Which one?
When you have cosine of x, you put the parentheses on x, or it's like...
Not necessary if it's just x. But if you have something different than x, like 2x, 3x,
But if we put it, it's okay.
it's okay. So you can put every time and it's going to be fine. Okay, fine. One more. You have a question, Dylan?
Yes. So the derivative of But the prime puede ser.
Yeah.
La derivada del coseno de x es menos seno de x.
Yes.
Yes. No, puede ser que
No, there are rules.
eso no me lo quieran decir.
Fine. Another example. Function I of x says 3x to the cube minus 5x squared plus 7x over 7x. Now, the thing is, in this case, for example, just at first glance, it will say, okay, quotient rule. But, can I simplify at the beginning?
Yes.
Okay, if you can simplify, the recommendation is do it. Okay? You can still do the quotient rule, and it's fine. But sometimes using the quotient rule will be something longer and more time consuming. I'll do both options. Simplify and not simplify, so you can see the difference. Okay? So option 1. Option 1, we're going to simplify. If I simplify, it means that I need to separate, right?
Yes.
So this divided by this divided by that, and this divided by this. When can I do this? When I have at 1/3 in the denominator, a monomial. That is not 7x plus something else, no, just a monomial. No plus, no minus. That's when I can simplify. Then 3x to the cube over 7x. 3x squared over 7 minus 5x squared over 7x over 7 plus 1. So you still have fractions, but now you can apply the power rule directly. So the derivative I prime of x is going to be the derivative of this one,
6x over 7.
6x over 7, very good, minus
5 over 7.
5 over 7 and 0. And that's the answer.
Wow.
Already simplified and everything. Question? Okay. The option 1 is if I simplify. I simplify, fine. Something easy to do. Power rule, that's my answer. No quotient rule. But the option 2 would be if in the exam, let's say, you forget about simplifying or you just don't see it. I can apply the quotient rule.
En el examen siempre simplificamos. Siempre. No.
That's the first step, always. If you can simplify or rewrite, you need to do it. But if you forget, you're going to do something else. But you're going to waste a lot of time. Yeah, the instruction will say, this is the function and the derivative. By applying any rule you want. Vamos a ir a clase. I don't recommend that, but
Y en el example 1, podemos usar la derivativa así normal.
vamos a las igual.
Porque no se puede simplificar nada.
Pero ya no puedes sacar ya la derivativa así.
By applying the rule.
But without that rule, not the normal
The
rule.
rule. If it's a quotient and it cannot be simplified, you need to apply the rule.
Oh, okay.
There's no other way. So it's not that, okay, the derivative of this is 1 and this is 1, so it's 1. No. I need to apply the rule. Okay then. Yeah.
What happened in the option 1? I didn't understand. So what happened to the one and the next?
Okay, yeah. It's one of the rules that you didn't see, so you weren't here. But what I did was, I just simplified. That's the first part. Second part, I need to find the derivative. The derivative is, you have a coefficient, you leave the coefficient, but the derivative of this is 2x. 2x times 3 will be 6x. When you have time, try to copy all the rules and try to practice a little, okay? The derivative of a number is 0. Okay, fine. Option 2. Let's try applying the quotient rule directly. So it's going to be derivative is going to be 7x times derivative of the numerator. 3x to the cube derivative 9x squared minus 10x plus 7 minus 3x to the cube minus 5x squared plus 7x times derivative of 7x? 7. All of that over 7x to the squared. Okay, so you observe it's a lot longer, but I haven't finished yet to multiply everything. So Yes, I know. 7x times 9x squared.
3x minus 7x squared plus 49 minus 41x plus 35x squared plus 49x over 49x squared.
Can I simplify a little further? Yes, I can.
49x, you can relate 49. Yeah.
Cancel these two. Add this one with that one. Add this one with this one, right?
Yes.
So 63 minus 21. Minus 70 plus 35. X squared over 49x squared, and then I can simplify 42 over 49, 6x over 7 minus 35 over 49, 5
over 7, yes.
not x, because it's x squared over x squared plus 1, which is the same answer. Which one is more complicated?
The first one.
The first one is more complicated? It's up to you, but the problem is in the exam. Come on.
O sea, si yo quiero desmetar un chorro porque te sobra tiempo hacer esa
Yeah, but we can use, like in this case, the original, that's the derivative in the second part.
Fine, I'll allow it. As long as I really put this.
Yeah, so we put it and then we want
Good. Questions? Okay. Before we do the activity, one more thing. If you observe here the parentheses are important. What do you mean by important? For example, if I just forget about the parentheses and leave it like this, is it the same?
No.
No. No, but it's a product of it. No, okay. Put a paréntesis. Es mejor que les sobren paréntesis que les falten. Entonces, mejor siempre que sea una multiplicación, pónganle paréntesis. Si les falta paréntesis, los puedo poner mal. Porque no significa lo mismo. ¿Qué? Se equivocan. Si no ponen paréntesis, no es una suma. Teníamos que saber eliminar aquí después. This is a new activity, 3.2.3. The format is the same, but it's not the same activity as yesterday. Okay? Huh? Fine, I'm saying that you need to have it. I'm just telling you that this is a new activity. Okay? Fine. So, like yesterday, I'm going to solve one for each part. Tomorrow, bring both activities so you can finish them in class. Tomorrow. 3.2.2, 3.2.3. Okay? Fine. Okay. This activity. The first part. Letter A. From the first five, which one seems the most difficult to you?
The first part?
No. From this.
La primera.
Okay, first one.
No, la segunda.
No, porque la
primera.
Fine. Do the first one. Okay. Number 2 is just long. It's not complicated. Number 3 is same thing. Number 4 again, like the one at the beginning. And the number 5 is you need to apply trigonometric derivatives. So number 1. Okay. Fine. Ready? Good. Okay. That function, can I simplify or rewrite?
No.
No, I can't. And remember, I cannot cancel because they are different. Now, so I'll apply the rule. Derivative will be denominator 2 to the x plus 1 times derivative of this. Derivative of this is 0, but this?
2 to the x.
I gave you the rule, remember? When you have a to the x, is a to the x ln of a. Minus numerator times derivative of the denominator, which is the same. 2 to the x ln of 2, and that's it.
Esa es la 3.3.
Yeah. Over 2 to the x plus 1 to the square. Yes? Remember, how did I get this one? With a rule. I gave you the rule before. Can I simplify? Well, multiply at least. So I multiply 2 to the x times 2 to the x ln of 2. Okay. Let me explain. 2 to the x times 2 to the x, it has the same base.
4 a las 2x.
You could put, for example, 2 to the x plus x, which is 2 to the 2x, which is what? 4 to the x.
No me ha puesto la 12.
Remember this or not? Okay.
¿Qué está pasando, doctor García?
A ver, si yo tengo dos potencias con la misma base, ¿qué pasa con los exponentes? Suman. Entonces me quedaría x a la m más n, ¿verdad? Que fue lo que hice ahí.
No se multiplica el...
Va. Si yo tengo así, ¿qué pasa? Ok, pues vamos por partes. Estos dos quedan así, ¿de acuerdo?
Sí.
¿Sí? Entonces, yo puedo ponerle que, por ejemplo, aquí tengo 2 a la 2 a la x, ¿sí o no?
Sí.
¿Sí o no?
Sí.
Ok, 2 a la 2, ¿cuánto es? ¿Sí me creen o no me creen?
Sí.
Claro. Más o menos. No, no puede ser la letra. Si queda igual, entonces me puede cambiar la base. Ok. Again. 2 to the x times this.
4 to the x.
ln of 2 plus 2 to the x ln of 2 minus this times this 4 to the x ln of 2 plus 2 to the x ln of 2.
¿Es nada minus? ¿Qué pasó?
Minus. cancel something?
Yes.
Yeah, this one with this one, right? So this times the same thing will be 2 times 2x ln of 2. 2x plus 1 to the square. Agreed? Is that the end? It's not.
Oh my God, that's great.
That's the answer. Do you understand why?
Yes.
Yes or not? Magic. Wow.
Porque la experiencia de dos es como tienen la misma base.
Yeah? Yeah or not yet? ¿Qué última parte? ¿De aquí a acá o de aquí a acá? De aquí. De arriba abajo. De arriba abajo. Entonces que este y este se cancelaron. Y este son lo mismo, ¿no? Como son lo mismo, pues es 2 veces eso. 2 por eso. Pero no puedo decir, pues va a ser nada más 4. No, porque aquí es 2, sí, pero aquí es 2 a la x. Entonces, ¿qué tengo que hacer? Bueno, me apliqué la regla. Mismas bases y aquí la potencia del 2 es 1. Entonces, nada más 2
¿Y si lo dejas así, está mal?
está incompleto.
Pero tendrías más puntos.
Pues más que arriba, sí.
¿Por qué fue x más 1?
Pero ¿por qué pusiste por ejemplo la cosa? Pero puedes multiplicar más, tienes las derivadas de...
Misma base. No. Because they're multiplying. They're multiplying the 2 with the 2. And then it's the other factor, so you leave it. So you don't distribute. No distributive. Oh, yeah. Yeah. Yeah? Fine.
O sea, la actividad de ayer de que primero usas la fórmula y ya luego le dices dos operatividades.
Okay. The second part, the table. Remember yesterday, same thing. You have a table with values. When you have x equal to minus 1, then f of x is 4. G of x is minus 2, f prime of x is 3, g prime of x is 1/2, and so on with the other ones. So from those 3, which one do you want me to do?
Tira del medio.
Okay. It's a division, huh? It says f divided by g prime of 0. So,
Y era como albañil.
okay,
Otra vez.
this one. Yeah. This one. Apply the formula. So it's going to be g of 0 times f prime of 0 minus f of 0 and g prime of 0 divided by g of 0 to the square. Now, before you ask, no, the answer is not 0. Because it's not the derivative of 0. No, it's a derivative evaluated at 0. Which is different. Okay?
Es que, o sea, los que están en el cuadrito chiquito son resultados, ¿verdad?
Así es.
Ajá, exacto. So, if I say G of 0, what do I do? G of 0 is what? Times F prime of 0 is what? Minus F of 0? G prime of 0? Over G of 0? To the square, okay? Do you get that? Yeah? That's part of the procedure, so you can put it or not. That's fine with me. Okay, that's the multiply part, the derivative part. Now, the arithmetic part, the easy part. Well, supposedly. Yeah. So, what do I do? Multiply. 3 square root of 2 times square root of 3? Good. Minus 2 over square root of 3 times square root of 2? Good. Over 3 square root of 2 to the square? 18. Why 18? 3 to the square is 9. Square root of 2 to the square is 2. 9 times 2 is 18. Is that my answer? No. Just understand this. Every time I say, is that my answer? 75% of the time. No. What do I do with this? That's another way to do it. But I'm going to find the. I'm going to rationalize.
No.
3 square root of 6 minus.
No,
Again, I'm counting the minutes. 2 square root of 6 over 3. Remember, I need to rationalize because I cannot leave square root in the denominator. Over 18. Is that my answer?
No.
Very good. Common denominator 3.
Para nada.
Literal nada.
Four. 4 times 2 is 8. 7 square root of 6 over 3 over 18. So the final answer is going to be
tortilla roll.
Ignora el ciclo y como lo quiso restar, lo puse por el tema de
Why 9 is square root of 6?
This is a fraction, this is not at the beginning. So the denominator for this is 1. Common denominator is 3. So 3 times 3, 9. The square root stays. 3 divided by 3, 1, and this is this. And then same square root, you can subtract the coefficients. 9 minus 2, 7. Square root of 6 over 3 over 18. Division of fractions. This times this. 52. 54. That's my answer. Yeah. Huh? But it's the same.
Easy for you.
No, it's for you. Okay. Listen. even though you should know this by now, in the exam I'm not going to put values as, well, complicated. You need to understand how to find the derivatives of this part. Okay? Fine. Next part. 1 or 2?
1.
Well, you start with trigonometric. One. Okay, now 1. Okay. For that number 1, we have 2 ways to do it. All are very similar, but kind of different. In what way? One way to do it would be to find the derivative directly with the rule, blah, 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 and then put the value inside, and with the gesture, remember? Another option would be to do something similar as with the table. How? I'll explain. For example, here, again, let's call this numerator f, and this one g, right? So, can I find f of e? F this one of e?
Yes.
Yeah, would be ln of what? Of e plus 1. ln of e is what? 1 plus 1? 2. Over that again. Now, g of e. What's g?
X.
It's x. Evaluated with e becomes just e. Right?
Okay.
5 minutes. F prime of e. Okay. The derivative evaluated with e is not the derivative of 2. No. It's the derivative of the function evaluated with e. So, what's the derivative of ln of x?
1 over x.
Derivative of 1? 0. So, 1 over x with e becomes 1 over e. Then, g prime of e. That is the derivative of g evaluated with e. Derivative of x? 1. So the answer is 1. Even though you have e, it doesn't matter. It's 1, it's 1. Now you have f, g, f prime, and g prime, and g squared. What do we do? Fill the formula directly. So now my derivative, f prime of x, well, that's my function here, f prime of e, is going to be g, which is what? E times f prime, which is 1 over e, minus f, which is 2, times g prime, which is 1 over g, which is e to the square. And then we simplify. E times 1 over e, 2 times 1, 2 over e squared. So the answer is that's the answer. Okay, so if you have a value, that's another alternative. If you don't have the value, you can put the quotient rule. But if not, there we go.
Wow. Teacher,
Yeah.
why did the derivative of e is 1?
What is the what? Sorry?
Derivative of e.
No. It's not the derivative of e. No. It's the derivative of the function g evaluated with e. I'll explain. G, I call this g, right? To maintain the notation. Is x. The derivative of this one is what?
1.
X derivative? 1. Evaluated with e, doesn't matter. It's going to be also 1. So that's why it is. It's not the derivative of e. It's the derivative of the function g evaluated with e, which is different.
Y como no tiene X, no la puedes evaluar.
Ajá. The other one had an x, that's why I put 1 over e, for example. Get it? Yes. Okay. The last part, and with that we finish. Yesterday I explained about the graph. The situation is the same. The situation, the only difference is that now instead of a product you have a division. But again, what do I need to find? I need to find the value of g, f prime, f, g prime, and g squared, right? This is the function f, this is the function g. This is my tangency point. Remember, this value pi over 6 represents what?
X.
X. And 0.5 represents which is f of s. Like y, yes. For this tangency point, this value is the x. And this value is going to be g of x. Why g and not f? Because the name of the function is g. The g that is here. So I have that, and I have this, and I have this. How can I find the derivatives? We saw it yesterday. With the with the slope. Yes, the slope. How do I find the slope of that tangent line? Yeah, but you have decimals, so it's in the square.
2 over 2.
With the points, G,
Yes,
Y,
which is minus over. Yeah? And the answer to this is the derivative evaluated pi over 6. Get it?
¿Y cómo se hace lo de
Yeah, in the exam, for example, I want only to do this without the calculator. So you have simple numbers, not fractions like this. But that's the idea. Okay? For this one, for example, if I want to find the slope, what do I do? Not the same, but I can use now these ones are easier. The slope is going to be y2, which is 1.128 minus 0.866 over 0 minus this one. And the answer is the g prime of pi over 6. Now you have everything. You can apply the formula. Do you understand that? What? Because that's the value of x. But this is the y2, y1, x2, x1.
¿Y por qué dio el resultado final bisexual? Ahora que lo hace.
Claro. El resultado final no es bisexto. El resultado final de la pendiente es la derivada evaluada en bisextos. O sea, el f' que necesito para mi fórmula. Y de este lado, la pendiente, su respuesta, o sea, el valor que me dé, es la derivada evaluada en bisextos. O sea, lo que necesito para f'. De nuevo, no es la derivada de bisextos, es la derivada evaluada en bisextos. ¿Sale?
Pero ¿por qué eran bisextos?
¿Vale? Porque eso es lo que pasa. Otro valor es otro valor. Bueno. ¿Sí? ¿Okay?